I can press stop up there when I'm done. So I'll just show you a couple tricks that I like. So this one, when you click there, this is true for all spreadsheets as far as I can see. Then I'm really selecting everything, and then I don't have data here, so I'm just doing a little bit of processing, a little bit of cleaning up my results first. So I'll delete that, edit, strike through, or delete. Yeah, I'll do that. All right, and I can always go really close to the computer. It'll probably pick up my voice better now. Is that cool, you guys? All right, and then this is actually mass measured in kilograms. And this is the period 4, 5, and 6 data, okay? And when you graph spring constant period, this is the original data. Now, a lot of people aren't doing this little step, which I think is really important. Always you want to know where your intercept is. So if I click here, and I go horizontal axis, and I make my minimum value 0, and then did you see the graph shift to the right? Now I have a better sense. And also notice with my data, I'm using a scatter plot. I always want you to do that in this class. I can't think of an example where you wouldn't use a scatter. And it really gives you a better sense of your data. Do you see this inverse pattern? I mean, it's pretty nice. And you can see it's asymptotic on both axes. This looks like an outlier, so I'd have no problem deleting that guy. In fact, there's a couple points that I'd have no problem deleting. Or not including, but I'll live with them for now. Okay. So another thing that you see how these points aren't. Not all our data is to the correct sig figs. So I'm gonna do that. I'm gonna choose like 3 sig figs. That's too many. There we go. That looks pretty good. 2 or 3. Maybe I'll go one more. One more out. Are you guys good so far? All right. So, and then this is my original graph. Okay. What do I do? What does this graph suggest I do? What does this suggest about the relationship when you get an inverse? Or a hyperbola, is that what it's called? Go ahead, yell it out. Good. What do I do to linearize this, please? Okay, so whatever's on the horizontal axis, I'm going to take the inverse of that. You could use either axis, but I'm going to want you to do the horizontal axis. All right, so I'll go back to data, and I'm not going to do anything to period, right? So I'll hit equals. I'll use the arrow keys, and I'll choose C1, which is the column for period. And then I'll actually highlight this cell and just scroll down. You guys know about this trick, right? Some of you don't. And then another trick is if you go on the edge of any at the top, watch what happens. I double click there and it resizes to fit better. And then I'm going to do, so I'm going to keep period on the vertical axis. And I'm going to do 1 over, is this what you guys said to do? 1 over spring constant? Constant. All right. And what units would that be, please? Say that again. I couldn't hear you. It's not newtons meters anymore. It's meters over, because it's 1 over spring constant. So meters over Newton. All right. Are you guys good? And now I'm going to teach the spreadsheet how to do this. I'm going to say equals. And spreadsheets know when you type in equals that you're going to do a formula. So I'm going to do 1 over. And I'm going to refer to cell B, that's B2, all right? And I'll hit return. And this is the only data point I have to check. Does that look correct? Is it doing what I want it to do? You can check that with a calculator if you want. And then I'm going to copy it. And it's copying the equation and doing the same thing for every row. And this is why computers got so popular in the 80s. That's why computers got in our home, because people realized they could do this for their money and their family budgets and stuff. They realized how powerful spreadsheets are. Change the world. Anyway, again, now we'd want a graph, right? Let's see what that looks like. So I'm going to do a quick graph so you guys can see. I'm going to go straight to scatter, as I hope you do. And then I'm going to customize it. Title. This is period. This is period versus 1 over k, right? Is everybody good? The horizontal axis is what? 1 over spring constant. Is everybody cool? Is everybody happy with this? And then you sound happy. How about vertical axis? What goes there? Period. All right. And then vertical axis, I need to put units. Horizontal axis, I think I forgot units. So what are the units again? Everybody yelled out. That was pathetic. Try again. Okay, meters per Newton. Good. All right. I think we're good now. The other thing I like to do is I like to put it in its own sheet, and then I label the sheet. So I go here, rename, and I describe what that graph is. It's period. I could use symbols. Capital T versus 1 over k. All right. And there's something else really important. Click here. What should my 0 be? My minimum value? Please watch as the graph shifts over. Because you would have thought this is kind of linear, but now when I shift it over, is it even possible for this to be a linear graph? And if you use logic, which you always need to do looking at data, like, okay, in order to go this way, in order for 1 over k to be close to 0, what does k have to be? I'll try that again. In order for 1 over spring constant to be closer and closer to 0, to be a small number, what has to happen to k? In order for 1 over k to be small, k has to get bigger. Yeah, k has to get bigger and bigger, right? So for large spring constants, that's going to the left on this graph. Smaller spring constants is going to the right, right? For smaller spring constants, does the period go up? That's what Marie said a minute ago. For bigger spring constants, does the period go down? That's again what Marie said. Are you guys cool with that? And if you have an extremely large spring constant, what's the only possible solution for the period? Like as the spring constant approaches infinity, what's the period got to approach? So should this intercept be 0? Now, once you see that, the idea that this is linear is thrown out the window because this has to be a side opening parabola. Are you guys good? So we have pretty amazing evidence here. This is actually really, really good data. We have good data to suggest that it's a side opening parabola. So now, what do we have to do? We have another linearization. Square what? Square what? Okay, so don't get confused here. If it were a top opening parabola, that's the kind that goes like this. That's like the mirror image of this. If it were a top opening parabola, you'd square the horizontal axis. But this is a side opening parabola, so you're actually squaring y-axis. It's like you're stretching out, to make this graph look linear, you're stretching out that axis. Can you envision that, sort of? So, so I'll go ahead and do that. I'll go back to the original data, and then I'll go to the top, and I'm not changing spring constant, right? So I'll hit equals 1 over spring constant. I'm leaving that alone. Again, this nice trick where you go to the edge of the top cell and double click, it resizes things. It's pretty nice. And then I'm going to copy everything down just directly. So I'm just really copying that column. The nice thing about doing it this way is if you find an error, everything will get fixed automatically, instantaneously. Like, it makes your lives easier. It should also save you time. So you said we do what to period? I don't hear you guys. So period squared. All right. So that's going to turn the units into seconds squared. Is everybody good? And then I'm going to do the trick again where I double click on the edge of the cell. Now it looks nice. I'm going to say equals. I'm going to choose, I'm using the arrow keys to navigate, right? I'm choosing that one times. And then I'm going to use the arrow key to go over there again. I'm just multiplying it by itself. And then I'll just copy that equation into all the cells. Are you guys cool? And then I'll graph it. And if you're lucky, it'll look like that. No. Go down to scatter. And I'll label my stuff. Chart title. Period. This is period squared versus 1 over spring constant. Okay. And horizontal axis, title, 1 over K. And this is meters per Newton. Newton's capitalized because it's named after a person. Vertical axis is period squared, which is seconds. I don't know. Raise your hand if that actually helps you to see me go through it. Yeah. Oh man, I didn't see a single hand. I'm sorry I wasted your time. I know it's a review. I did notice that. Oh, we need an equation here too, guys. Hold on. So I'll go to edit chart. I forgot to put the equation in. So this is a little tricky. People forget this. Put the legend inside. All right, because the legend is going to become the equation. All right. Then under series, go add trend line, linear trend line, label, use equation. Now I have the equation. Period squared equals 13.5 times 1 over K plus 0.17. You guys cool now? And the reason this intercept isn't 0 is I still haven't taken care of my outliers. And I would argue that some of these outliers are impossible because, take this one for example. This is related to K, and K is the spring, right? Can you have a spring with the same K, but a different period? That's what this would be. Same with this one. They're directly vertical. You can't have different periods, especially this one is really weird because you'd have way different periods. So I'm skeptical of these data points. I think maybe the period was measured wrong or the spring constant was measured wrong. So I would actually not include those in my analysis. And you notice the graph will shift and be closer to a 0, 0 intercept. You guys good? If you're justified and you can explain why a data point should not be included in the analysis, then you're justified in doing it. Does that make sense? And we have so much good data, we really don't need to include these outliers because this isn't a big percentage of our data, right? So that's how you would go about dealing with those. Anyway, I'll press stop and I'll put this on Classroom if anyone wants to review it.